Hi guys, I hope you are fine. Me too, I am fine. So today guys, we are going to attempt these two questions. And these questions are differential equations, and we do them by separating variables. That is, we put variables of the same kind in one side and of the other kind in the other side. So that now when we come to the first one, we are going to put our y's and dy on one side and our x's and dx on the other side. So we shall have, for example, for this one, we shall write dy. You can put that dy on one side and then bring along y squared. So when it comes to this side, you shall have 1 over y squared like that. And then this one will now give us x squared, and now we bring up dx this side like that. So from there guys, we come and now integrate both sides. So this side we shall put integral. First of all, let me just write it the way it is, like that. Dy, this other side x squared dx, like that. So that now guys, I can now integrate this side. Maybe I could write down here. I integrate that side, 1 over y squared dy. This one will give us, you integrate this other side, x squared dx, like that. So when we integrate guys, this is what we are going to get. This one is going to be, you can bring y on the upper side, so that now you shall have integral of y raised to -2 dy equals to integral of x squared dx, like that. So finally guys, we are going to have, we integrate that one, we shall have y, and -2 plus 1 is -1 all over -1. This one gives us x cubed all over 3 plus now c. We can rearrange that equation guys, and this is what we get. You'll have 1 minus 1 over y, like that, equals to x cubed all over 3 plus c. So we can now multiply by negative both sides, or we can even leave it like that guys. So now we can have, if we multiply both sides by negative and then bring this x raised to 3 over 3 on this side, we shall have something like this guys. We shall have 1, let me write with this, we shall have 1 all over y, like that, plus x cubed over 3. This is equals to c. So we have gotten that by multiplying this side by -1. This side we have multiplied by -1. But please note guys that since this is a constant, it can be negative or positive because we do not know what is the constant. So this is going now to be our solution, guys, for that question. That is our solution. Going to the next question, and we write it down. Here is our next question, guys. This is Roman 2. We have x plus 1 like that, dy dx is equals to x y squared plus 1 like that. We can now separate the variable, bring y's on one side and x's on the other side. Well, what we make sure is that the dy or dx is going to be a numerator. So for this one, we can leave the dy that side, and then we can bring this y squared plus 1 this side. So this one is going to be like this, guys, all over y squared plus 1. This one will give us, now for x we leave it there, we bring this x plus 1 this side, and then we have the dx coming here. This is our dx. From there, guys, we should remember this, that differentiation of tan inverse x, this one gives us 1 over x squared plus 1. That is the differentiation of tan inverse x. So that now when, guys, we come and integrate both sides, we integrate this side and we integrate this side, so that this side now we shall have tan inverse y. This one now is going to be equal to, for this one we can use partial fraction, and this is how we do it, guys. We'll come here, let me just draw something here, a line here, guys, like that, so that we can now divide. When we are doing partial fraction, this one should be raised by a figure which is lower than this, at least by 1. But now, because they are the same, we have to divide. So we divide x plus 1. In other words, we divide x by x plus 1. And by dividing, we look for a number that if you multiply, you get x. That will be 1. And here we shall have x. But remember, this one is going to come to x plus 1, like that. So here it's supposed to be x plus 0 because it's only x. So if I come and subtract here, we are going to have 0 minus 1. You'll have x minus x is 0. Then you'll have negative 1 as your remainder. This is a situation whereby, guys, you can think of 4 divided by 3. Now, when you say 4 divided by 3, this is the same as putting 1 and 1/3. So 4 is divided by 3, just like this x is divided by this. So this one being like our 3. So for this now equation, you will have, it will be equal to, maybe I can write here, it will be equal to 1, which when you divide this by that, you get 1 remainder this. So it will be 1. Now remainder, this 1 is the one here. So it will be minus, now 1 all over 3. Our 3 for this is this. That is x plus 1. Like that, guys. So that now here we shall have something like this. We shall have 1. This one now will be separated into 2. We shall have 1 dx minus integration of 1 all over x plus 1. Like that, guys. Dx. Like that. So finally, guys, we are going to have something like this. We shall have tan inverse y. This one now will give us, if we integrate this one, we shall get x minus, integrate this, we shall have ln x plus 1, like that. Now plus c, like that. So finally, guys, our answer then is going to be equal to tan inverse y equals to x, because integration for that one is x, minus ln x plus 1 plus c. And there we come to the end of our question, guys. So that's how we do it. So God bless you guys, even as we continue together. So that is how that question should be done. Bye bye.